A parabola is the shape of the graph, the type of graph that we get when we graph a quadratic function. And parabolas have a lot of special properties. One of them is that they're symmetric about their axis of symmetry. So we want to take a look at that symmetry and what it means for our graphs. So let's take a look at this example here. We can see that this function here, or this graph here, is concave down. As it opens down, the arrows point down in both directions, which means that the vertex up here is a maximum value. This ordered pair here is at 3, 2. So our vertex, which is a maximum, because it is the very top of our graph, is at 3, 2. What we can do from here is identify the axis of symmetry, because our axis of symmetry goes straight through our graph, straight through the vertex, through the center of our graph. And it has the equation, as all vertical lines do, of x equals the x value that it passes through, in this case 3. So recall that the axis of symmetry has the same x value as the x value of your vertex. In this case, x is equal to 3. And what we can identify from here then is that every single ordered pair that's along the same horizontal line, meaning they have the same y value, for instance, -16 here, -16 here, are equidistant from the axis of symmetry. So this ordered pair here on the left, 0, -16, is 1, 2, 3 units away from our axis of symmetry. Which means I know this is a pretty poor quality graph, but we don't need it because I can count 1, 2, 3 spaces to the other side. If I start at 3 here, I go 4, 5, 6. Takes me to 6, -16. And that's going to happen for every ordered pair along the same horizontal line. They're equidistant, they're the same distance from the axis of symmetry as long as they share the same y value. So the same would be true for these x-intercepts up top here. We've got 2, 0, and 4, 0, each of which are 1 unit away from the axis of symmetry. Because of this symmetry, what we can do is identify points, identify axes of symmetry and vertices on parabolas based on just some given information. So for instance, for number 2 here, if the axis of symmetry of a parabola is at x equals 2, and one x-intercept is at 6, 0, we can identify the other x-intercept. Let's graph. If the axis of symmetry is at x equals 2, that's the vertical line that goes straight through the x value, x is equal to 2. It's vertical, it goes straight up and down. This is our axis of symmetry. Again, x is equal to +2, which means our vertex is going to have an x value of 2. Now, one x-intercept is at 6, 0. So I've got one ordered pair here at 6, 0. Now, I don't know what my vertex is. I don't have any other ordered pairs on this graph, but what I do know is that I am 1, 2, 3, 4 spaces away from that axis of symmetry. So what I need to do is count in the other direction, 1, 2, 3, 4, to land myself right here at -2, 0. Because of that symmetry, because we're equidistant along the same horizontal line, our y values are the same, we have the same distance away from that axis of symmetry. So the other x-intercept of this particular parabola is at -2, 0. There are lots of different things we can identify based on this. That's just one example. Let's take a look at this example here. If I have a y-intercept at 0, -1, 0, comma, negative 1, and my axis of symmetry is at x equals negative 3, we can name one other point on the parabola. So let's again graph. 0, comma, negative 1 is right here. 0, comma, negative 1. And my axis of symmetry is at x equals negative 3. Again, that's a vertical line straight up and down. Goes through that x value of negative 3. Because it's a vertical line, it has the equation x equals the x value that it passes through, in this case, negative 3. So we're counting again. How far away are we from the axis of symmetry? In this case, 3 units. So we'll just continue on the other side of the axis of symmetry. No matter what, we know that our y value is going to be the same. We're going to have a negative 1 right here. And if I count 3 units away from that x equals negative 3 line, we end up at x equals negative 6. So one other point on this parabola is negative 6, comma, negative 1.